Good morning, my students, and welcome to physics. We are going to study now Faraday's law and electromagnetic induction. If you have a moving coil galvanometer, which can be used to detect the direction of the current intensity and measure very weak current intensity and determine the direction of the current intensity. If you have external magnet of south pole or north pole belonging into a solenoid, what happens? Change in magnetic flux density takes place, which can be observed. This is the induced current, which can be observed due to the deflection of the pointer of the moving coil galvanometer, and the current move upwards. We can determine the direction of the field by using this current, which is called induced current, by applying Ampere right hand rule. If the other fingers of right hand points to the direction of the current, the south point to the direction of the north. This means that if the north pole, this is the south pole. When we belong north pole with south pole, we observe that repulsion takes place. Repulsion takes place. Repulsion takes place, which can be observed by using Lenz's rule. Of this experiment is reversed. The magnet move away, pull it out from it. What do you observe? The direction of the current is reversed, and the direction of the current can be observed from the moving coil galvanometer is reversed in the opposite direction. This means that the direction of the current depends on the direction of the magnetic field, the direction of motion, blowing it into and pull it out. When the direction is reversed, the direction of motion of the magnet is reversed, the direction of the induced current is reversed. When we use north pole instead of south pole, we observe that the direction of the current is reversed. This means that the direction of the induced current depends on the direction of the magnetic field and the direction of motion of the current. This experiment can be classified by using the following. When we connected the terminals of the coil with the sensitive moving coil galvanometer, or microammeter, or milliammeter, or galvanometer, or sensitive galvanometer, having zero reading in the middle, to determine the direction of the current, to produce current is called alternating, move up and down. This current is called alternating current, not direct current. When Faraday is blowing the magnet into the coil, what happens? This is the observation. The magnetic needle deflected momentary during the motion only in a certain direction. When he removed the magnet from the coil, what happens? This is the observation. The magnetic needle deflected momentary, but in the opposite direction. The same effect appears when the coil is moved, but the magnet is stationary. This experiment is repeated. The conclusion of this experiment, we observe that induced electromotive force and induced current are generated in the coil as a result of time variation of magnetic flux linked with the coil. Induced electromotive force and induced current are produced due to the variation of the magnetic flux linked with the conductor. And the time of variation of the magnetic field lines turns of the coil intercepted while the magnet was in motion, intercepted, changed, cutting it. The direction of the induced current depends on the direction of the magnet of motion and the direction of the magnetic field north belong to the solenoid, while or the south pole of the magnet belonged inside the solenoid. The direction of the induced current, we can determine the direction of the induced current generated in the coil by using Lenz's rule. Lenz's rule, it is a very important rule. Lenz's rule can be used to determine the direction of induced coil in a coil, while we can use Fleming's right-hand rule to determine the direction of induced current when electric current passing through straight wire. In straight wire, we use Fleming's right-hand rule. In a coil, we use Lenz's rule. When we approach north pole of the magnet, the induced EMF is formed in a certain direction, forming like pole, magnet repulsion. When the direction of the magnet, this magnet is belonged into, with the north pole, electric current move is called induced current. We can determine the direction of the field by using Ampere's right-hand rule. If the other finger of right hand points to the direction of the current, this is the direction of the current. The thumb will point to the direction of the field. This is the direction of the field, north pole and south pole. We observe that north facing to north, repulsion, repel each other. This is determined by using Lenz's rule, but not by using Faraday's. If you approach south pole instead of north pole to the magnet, north, south direction of movement plunged into, we observe that the direction of the current is reversed downwards. This means that this is the north and this is the south pole. South facing south. At the first, north. At the second, south. This means that repel each other, like pole repel each other. This means that when we approach any magnet to the solenoid, the same pole of the magnet is formed facing to it and repel it. This means that induced EMF is produced whenever in a direction that opposes the change producing it. When this experiment is repeated by using north pole and far away pull it out, when we pull it out from north, the other side is called south and attraction force is produced. When we move out south pole, north pole is formed and attraction force are produced. This means that when we belong to coils, the same pole is produced. When we remove it or pull it, we observe the opposite pole is produced. When we're moving away, north pole or south pole from the coil, induced a certain current will produce direction forming unlike pole, opposing the motion of the magnet, or attraction force can be observed. From Lenz's rule, the direction of the induced current, which is generated in the conductor, depends on the direction of motion, the direction of the magnetic flux, which determine the type of the magnetic pole of the magnet. From this, we can deduce Faraday's law. This is the Faraday's law. Faraday's law at first, when we use two magnets instead of one magnet, the change of magnetic flux, the rate of change of magnetic flux increases, and the deflection of the wire of the moving coil galvanometer increases. This means that induced EMF increases, and the relation between them is directly proportional. This means that the magnitude of the induced electromotive force is directly proportional with the rate of change of the conductor intercepted with the magnetic flux linked with the conductor, which is called the rate of magnetic flux. Delta T means rate of change of magnetic flux. If this experiment is repeated by using another solenoid but it has big number of turns, the big number of turns make more change. So induced EMF increases, or epsilon EMF or epsilon. EMF induced directly proportional with the number of turns, because by increasing the number of turns, induced EMF increases. The magnitude of induced electromotive force is directly proportional to the number of turns of the coil which intercepted or linked with it, the magnetic flux lines. This means that epsilon induced directly proportional with the number of turns of the coil and the rate of change of magnetic flux. Rate of change of magnetic flux. We can remove the proportional sign of proportional by equal constant. Time is n delta phi m over delta t. Scientists say that constant equal unity means that equal 1. Epsilon induced equal n delta phi m over delta t. This is Faraday's law. Faraday's law. Faraday's law induced EMF equal the product of number of turns of the coil and the rate of change of magnetic flux. What does it mean? The point, the negative sign. Negative sign indicates Lenz's rule. When we approach the magnet, we observe force away, repel it. When we move away, we observe force attract it in the opposite direction. The minus sign, negative sign indicates the opposite direction. If the magnetic flux is measured by Weber, this is the unit for measuring of magnetic flux is called Weber, but magnetic flux density is called Tesla. The unit of it is called a Tesla. This is no Faraday's law, electromagnetic induction. Negative sign indicates that the direction of the induced EMF or the direction of the induced current to oppose the cause of producing it according to Lenz's rule. According to Lenz's rule. According to Lenz's rule. Faraday's law. Induced EMF is generated in the coil by electromagnetic induction is directly proportional to the time rate by which the conductor intercepted line of magnetic flux, also proportional to the number of turns of the coil. The average induced EMF is measured by volt. The change in the total magnetic flux linked with the measure in the Weber, which measured by Weber, and which is equivalent to volt second. Volt second because delta phi m equal EMF dot T over N. N is the number of turns has the unit for measuring. EMF volt, time second equal delta phi amp equal Weber. This means that the equivalent unit for Weber equal volt second. Goodbye and good luck, my students.